We're all spending more time online doing shopping, banking, streaming, social media, and we rely on secrets to prove that we are who we say we are. But our credit card numbers aren't secret because we give them out to everybody, right? And CISOs, cover your ears, we reuse passwords, like all the time. And if you tell us that we've got to put a number in the password, we just stick a 1 on the end. So we're all susceptible to identity theft and fraud. And as you can see from these numbers, it's a problem that's only growing alongside e-commerce. Kount was started in 2007 in Boise, Idaho to protect digital interactions, and we've also been growing. Recognizing our strengths in AI and unique data, Equifax purchased Kount last year for $640 million. Our original product evaluates e-commerce payment transactions while you're checking out. This takes under 250 milliseconds. We decide whether it's you who's using your credit card. That's less time than it takes to blink. The combination of this short end-to-end SLA, processing hundreds of transactions per second, and having less than 1 hour per year of downtime is tricky. About 6 years ago, we started building everything new in the cloud. We picked AWS because we really wanted to lean into managed services to save on operational costs. And AWS's managed services are well suited to these short latencies and the types of data patterns that we had. Last year, we started migrating our core payment fraud product into the cloud so that we could get all the way out of the data center. Now, the architecture, the legacy architecture that we were starting with is a PHP monolith wrapped around a large database instance. I always have to tell the new folks when they're coming on board and they see this, and they go, ew, that there's a reason it was done this way. 15 years ago, if you wanted to run as fast as we have to go with all of the data that we've got to have on hand to evaluate these transactions, you had to have one big data store. And then PHP, for all of its limitations, is a fast, single-threaded language that's well-suited to these types of API calls and responses. So this architecture met our principles of the time. It's always important that you start with these architectural principles. And they were availability, stability, and latency. But when we wanted to build new products, we can't reuse any of this monolithic architecture. So when we went to AWS, we moved to a microservices architecture using Go and Python. And that was a decision we came to after coming up with our new principles. Availability remains. And stability and latency are still really important to us. But architecture is all about trade-offs. We need to have effectiveness and scalability to be able to support our aggressive new product roadmap. We don't have the time to build a new monolith for every product that we want to launch, even if it's going to run really fast once we do. Now, I know this slide doesn't look simple, but it is a simplified version of one of our product architectures in this new microservices approach. Someone buys something over here on the left from one of our customers using your credit card. We've got to decide if it's you or if it's a fraudster. That request comes in and gets routed to our payment fraud orchestrator, which runs across the top. And it starts calling microservices. First, validation, standardization, then data augmentation. We do graph linking to build a network view of the transaction in context, encoding and those lookups. We build machine learning features, then run through a machine learning model. Finally, take all of that data and run it through our policy engine to come up with the decision, approve, decline, or hold for review. That gets passed back to the customer, again, in less time than it takes to blink. You can see that each of these microservices can have a different data backend instead of using that one central repository. So we use things like RDS, ElasticSearch, DynamoDB. The orchestrator is also responsible for journaling over on the right. Journals for audit trail, business intelligence, and billing. And then across the bottom, you can see our customer portal, where our customers can log in, evaluate transactions, and make those decisions, use the business intelligence tools, and write rules for the policy engine. Now, this architecture has a lot of advantages, but the advantages each come with challenges which we've worked to mitigate. So this architecture is scalable to both more volume and to more orchestrators that implement new products. But we pay for this with complex infrastructure to make sure all the services can handle the throughput. So we manage that with AWS managed services wherever possible, and we use Terraform for infrastructure as code. We get to have frequent small deploys of these microservices, but they can have unexpected interactions with each other. So we've automated end-to-end testing and use GitLab to manage our pipelines for CI/CD. We can also have a service ownership support model. This gives our development teams skin in the game because they have responsibility for the services after they've deployed them. But the challenge can be that if you see something going wrong at the top level, it's not always clear which service or services are responsible. So we use Datadog for distributed logging and tracing, and OpsGenie for alerting. Now, the big benefit for data is the encapsulation. Microservices only need to know about the data that they need to do their specific task. But that's also the limitation, because the data is fragmented. And there are some times when you want to have it all in one place, notably for business intelligence and machine learning. So we use Snowflake for distributed warehousing of the data. Finally, microservices only do one thing. That's the whole point. But if you want to build something complex, like that last slide I was just showing, it means you need to put a lot of these microservices together. And every time they talk to each other, you're going to pay a 5 or 10 millisecond overhead just in that communication. So we handle some of this by using gRPC instead of RESTful calls internally. But the rest we deal with by parallelizing these services from the orchestrator. And this is the end result. This is a view from our tool. We kicked off this product at the beginning, or this project at the beginning of 2021 with a one-year plan that was immediately challenged by events. The Great Resignation, being acquired by Equifax. But we hit our platform objectives, and we built to market parity with our existing product. So everything we're doing now is adding more capability. We found ourselves in a much larger identity and fraud strategy within Equifax. And we're now pulling data from Equifax's data fabric, which is implemented in another cloud service provider. But our AWS microservices don't care where this data is coming from because of the encapsulation. Our product roadmap looks very different today than it did when we started this project, but our design hasn't changed. And that's the best validation of this microservices approach. The whole point of this thing was that we would build a bunch of microservices that can be orchestrated together to generate new products that we haven't even thought of yet. The fact that that's worked means that our real-time, low-latency artificial intelligence from Kount, combined with Equifax's differentiated data products, will supply the new Equifax digital services moving forward. Thank you for the opportunity to come up here and tell our story, and may all of your migrations take you somewhere you're not embarrassed to call home.